In this video, I am going to show you how to not only graph the function negative x squared plus 4x minus 5, but also understand different features of the graph. First question, state whether the graph of the parabola opens upward or downward. To determine this, you look at the coefficient a. A is the coefficient of the x squared term. If you look at the standard term, ax squared plus bx plus c, a would be -1 in this case. And because -1 is less than 0, you should expect the parabola to open downward. That looks like that. Now, we need to determine the vertex by two different methods. I'm going to show you different methods, and then you will have a choice to pick whichever method that works best for you. So method number 1, completing the square. Let's rewrite the function. The first step we want to do is to look at the two variable terms, and we are going to factor out the leading coefficient a. So the coefficient a here is -1. Factoring -1, I should have x squared minus 4x in parentheses, and then just bring down the -5. Next, I need to be able to write the x squared minus 4x and maybe adding something and minus something so that we can write it as a perfect square somehow. To figure out what goes in these spots here, we are going to look at the middle coefficient in the parentheses. In this case, the middle coefficient is -4. -4, we're going to call it the b value. So b over 2 squared, we will look at b over 2 squared. b is -4 over 2, and then squared. Simplify this. In parentheses, we should get -2, and then squared, and that will give us 4. So we should put +4 minus 4 in here. Next, these first three terms will become a perfect square. So we can write it as x minus 2 and then squared. The quick way to figure out this value, -2, is to look at b over 2. Remember b over 2, we did it on the side here, but let's look at that again. b over 2, b, which is the coefficient of the x term in parentheses, b is -4, then divide by 2, that gives us -2. So because that's -2, here, the perfect square, you would have -2. Now, we still have this -4 in here, but we want to move it outside. So to move it outside, you are going to distribute the -1 with the -4. -1 times -4 gives you +4. And then finally bring down the -5. Now we just have to combine these two constants. And we don't have to write the 1, just write negative. And then x minus 2 squared minus 1. Now we have the vertex form. To determine the vertex, we are going to look at the vertex form, which is a times x minus h squared plus k. Now the function here looks almost identical to the formula, except the part plus k here, we have -1 instead. So we could rewrite it a little bit. We could do negative x minus 2 squared. So that still matches with the x minus h squared. And then plus, we want plus k, so we're going to write plus a -1. Now that should still give us -1. We're not changing the value of the function, but at least now all the signs match up with the formula, the vertex formula. So the vertex would be the point hk. H is the x-coordinate of the vertex, and k is the y-coordinate of the vertex. So h in this case is going to be 2, and k in this case is going to be -1. So the vertex is 2, -1. So that's completing the square. Now, method 2, using the vertex formula. So to find the vertex, you calculate h. H is calculated by -b over 2a. Now, let's look at the function again. In this function, in the original function in standard form, a is -1, b is 4, and we actually don't need the c, just a and b. So b, plug 4 in for b, and -1 in for a. Here we should have -4 over -2, which gives us 2. K is calculated by f of -b over 2a, which means the function f evaluated at x is equal to -b over 2a. Now, we already calculated -b over 2a to be 2, so really we're looking at f of 2. So to calculate f of 2, again, we'll look at the original function here, and we're going to substitute 2 in for x. So we have -2 squared plus 4 times 2 minus 5. Following the order of operations, we need to do exponents first. So perform 2 squared first and then apply the negative. So that's going to be -4. 4 times 2 is 8 minus 5. So that should be -4 plus 8 is +4. +4 plus 5, that's going to give us -1. So the vertex is going to be HK, which is 2, -4. And that matches with the answer that we have by using completing the square. Now in this step, if we want to write the function in vertex form, we can. The vertex form is a times x minus h squared plus k. So then a, we found up here is to be -1, so just write negative. X minus h is 2 squared, and then k, we found it to be -1, so just write -1. And then we get the same vertex form as what we have over here on the left. Next, determine the x-intercepts. To find the x-intercepts, we need to let the function be 0. So we have two options. We can use the original form, the standard form of the function, and set it equal to 0. You could try to factor this function. You could also use the quadratic formula if you want, or if you prefer the square root property, instead of using the standard form, we can use the vertex form and set that equal to 0 instead. So, or. Now we can solve. First, we are going to add 1 to both sides, so this will give 1 here. Then we can divide both sides by -1, and that will give us -1 over on the right. And then on the left, we just have x minus 2 squared. The next step should be taking the square root of both sides. But on the right, notice that we have a negative number, and we can't take the square root of a negative number. And so there would be no solutions in this case. No solution here means no x-intercepts. Okay, now to find the y-intercept, you just let x be 0. So for this one, you can plug 0 in for either the standard form or the vertex form, whichever you prefer. I can use the standard form. So if we use the standard form, which is this form right here, we would have -0 squared plus 4 times 0 minus 5. And then you should just end up with -5. So the y-intercept is the point 0, -5. Now the next question is to sketch the graph. So it would be nice if we have 4 or 5 points. Unfortunately, because there are no x-intercepts, we only have 2 points to work with. And the points are 0, -5, and the vertex, which we found up here to be 2, -1. let's plot those points anyway. So 0, -5, that's going to be down here. 2, -1, that's going to be right here. Now, what else do we know about this graph? You know that it's going to open downward, which we figured out in part A. We also know that if we draw a vertical line through the vertex, that's going to be the axis of symmetry. That's the line that divides the parabola in exactly half. So we could reflect another point over here on this side of the vertical line. It's a reflection of the y-intercept, the point 0, -5 that you see here. So you get another point. Now that still doesn't seem, we could kind of picture the parabola sort of going this way, but I would like us to be a little bit more precise. So I'm going to add an additional point. Okay, we're going to add an additional point. So what we can do is just kind of pick an x value, say x is equal to 1. So if x is equal to 1, and then we'll try to figure out what the corresponding y value is going to be. So I could use the standard form of the function. You're totally welcome to use the vertex form if you want. Substitute 1 in here. Okay, so then we get -1 plus 4 minus 5. -1 plus 4 is 3. 3 minus 5 is -2. So the point we want is 1, -2. 1, -2 is right here. Now with the axis of symmetry, I can totally reflect another point over here. So now we can draw the parabola with a little more detail. Okay, so there's our graph. As you can see, there's no x-intercepts. The graph does not cross over to the x-axis at all. It's just floating underneath the x-axis. Axis of symmetry is the vertical line that is described by the equation x is equal to a constant. In particular, it's x is equal to h. In this case, h is the x-coordinate of the vertex. This vertex here was 2, -1. So x is equal to 2 is what you want to write. There would be a maximum point here. Just look at the parabola opening downward. You will see that there's a peak. The maximum value for the function would be the value -1 at the vertex at x is equal to 2. Domain is always going to be -infinity to infinity. Range is the lowest point, which is -infinity, to the highest point, which is -1. And we do include -1, so we're going to use the brackets there.